All right, this time we're going to be working on verifying solutions to one-step single variable equations. So you're not being asked to solve these equations on this particular assignment. Um, you're being asked to verify, which means to check or to make sure whether the given solutions that I've written in my handwriting here are indeed the solution to the equation they're next to. So some of them, the solution that I give you will be the solution. And you have to say that. If you check it and it turns out to be right, then you would say, yes, this is the solution. And some of them you will check and see that they're not the correct solution. They won't work per se. And for those, you say, no, this is not the solution. There's a couple reasons why you're doing this. The first one is to help you understand the definition of a solution to an equation. So remember this definition is something you're supposed to be able to repeat back to me in class if I ask you. The solution to an equation is a number. So in this case, maybe it says 3. We don't know for sure yet, but it's a number that when substituted into the equation for the variable makes the equation true. Okay, solution to an equation is a number that when substituted for the variable makes the equation true. Now, as you continue further on in your math career, you'll see that solutions to equations can actually be other things, sets of numbers, other mathematical objects. But for right now in 7th grade, it's just a singular number for us. So we check it. We're going to check whether or not this is the solution by using that definition. We will substitute it for the variable in the equation and then see if it makes the equation true. If we come to something very obviously true at the end, like 5 equals 5, then we say, yes, it's a solution. If we come to something very obviously untrue at the end, like -2 equals 10, then we say, no, it was not the solution. All right, so I think what I'll do is I'll do half of them and leave the other half for you to do. I'll try to pick the more challenging ones though. All right, might as well start with number 1. 10 minus r equals 7. And I'm proposing, meaning like suggesting, that 3 is the solution. You could probably just look at it and say, yeah, 3 is going to work. 10 minus 3 equals 7. But a lot of what we're doing in this algebra unit is learning how to write things properly, how to show our work the conventional way. And so it is an expectation that you're writing this stuff similarly to how I'm going to do it. I'm going to rewrite the entire equation, except I'm going to make a substitution. Instead of r, I'm going to write 3. Okay, now I will go down to the next line for each like group of operations that I complete each time. So I only have one operation that needs to happen here, right? 10 minus 3, which is 7. So that's happening on this side of the equal sign. So I'll write it on this side of the equal sign. But I still have my whole equation. I still have this equal sign and I still have this 7 over here. And now I pretty much can't go any further, right? I've got something that's very obviously true. 7 equals 7. That means this solution did work because it made the equation true. And so we write, yes, 3 is, you could say a solution or the solution. Either way is okay in 7th grade, I would say, is the solution to the equation. And I like to abbreviate equation as EQ. All right, might as well just do the one directly underneath, right? Let's go down to number 3, change colors here. We got 4 equals 3 minus v, and we're checking to see if -1 is a solution here. Okay, so again, let's start by rewriting the entire equation the way we see it. And let's be really careful with our minus and our negative sign here, because that's going to make the difference as to whether or not we get this question right. This says 3 minus v. And then v itself is supposed to be -1. So we're going to have a minus -1. I don't want to put a minus and a negative symbol right next to each other. That's bad form. So I'm going to put this number in parentheses just to separate those symbols a little bit. And now we have the equation 4 equals 3 minus -1. Let me go down to the next line to show my operation. 3 minus -1. Well, thinking about adding the inverse like we learned in the last unit, minus, we can change that to plus, but then when we do that, we have to invert the next number so that -1 becomes a +1, and now we have 4 equals 3 plus 1, which is obviously true, but let's write it properly. 4 equals 4. We want to keep our whole equation every time, not get messy and switch from writing equations to like scratch work or separate things. Okay, so obviously this one turned out true again, so we write yes. A common mistake I see with students when they're first doing this is accidentally writing this number in their conclusion. The number that you get at the end when you're done like solving or verifying, I shouldn't say solving, we're verifying. That's not the number that should be a part of your conclusion because that's not the thing you're being asked. You're being asked whether or not this number up here was a solution. So this is the number you should be referring to in your conclusion. Yes, -1 is a solution. We can stop there. I suppose you don't have to write a solution to the equation or whatever. We know what we're doing. Let's see. Let me see if I can pick one where it's not going to work out. That way we can see that. What about the next one? Yeah, so the next one's a tricky one that I bet some people will get wrong. So we'll just go right down to that one. Change colors again. We'll go with this orange. It says 4 equals -5 minus 1. Okay. I need to substitute this 1 in for n. So I rewrite the entire equation the way it looks. Actually, now that I relook at it again, it's not as tricky as I thought, but still it's going to come out as not a solution, which is what I wanted. So 4 equals -5 minus 1. Now I could see some people getting what number needs to go over here wrong, but most people will probably get it right as to whether or not it's a solution. So let's think, -5 minus 1. A lot of people would get this wrong and say -4. But if we use our adding the inverse skills, I'm going to switch to a different color so you can see what I'm doing here. I'm going to change this -1 to plus -1. So I'm sneaking a little negative sign way up high there. Now I see it as -5 plus -1, which makes it a lot more obvious to tell that the answer to that is -6. So now we're writing an equation that isn't going to make a whole lot of sense. It's going to be clearly wrong. We're going to write 4 equals -6. Well, that's not true, right? So we have a way of indicating that. We can slash out our equal signs to say 4 is not equal to -6. And since this proposed solution didn't make the equation true, let's write no. 1 is not a solution. Yes, you do have to do this part every time because you're being asked a yes or no question. Is this the solution, yes or no? So I need a yes or no answer. If you didn't do that part and you just wrote this, I would look at it and say, okay, this person knows how to substitute into the equation well. This person did -5 plus -1 correctly. That's great. But do they know whether or not this is a solution? Like, do they know what they're doing? What conclusion to draw here? So you got to show me that you know all the different pieces of what you're being asked here. All right. I guess we'll just keep on going down the line. I guess, yeah, I'm probably just going to wind up doing this left side here. How about some purple? We got 2 plus n all over 3 equals 3, and n is supposedly 7. Let's substitute that 7 in there and see what happens. So we got 2 plus 7 for n, all over 3, supposedly equals 3. Okay, so sometimes when you're dealing with rational expressions like this, when you got a fraction bar in there, we call that a rational expression because it's making a ratio. Sometimes it gets harder to move down each time you want to write a new line or step because they take up like double lines. And so if you have to use arrows to move over to the side instead, that's also okay. So I'm going to write my next step below where I'm only going to do my first step, which is things that are grouped together. Wait, what's grouped together here? Well, the 2 and the 7 are grouped together because they live together on top of this fraction bar, meaning, hey, you got to do this 2 plus 7 before you can divide anything by this 3 down here, right? So 2 plus 7 is 9. We got 9 over 3 equals 3. Okay, we got one more operation to complete here now. We got to do 9 divided by 3. So I'm going to use an arrow to help me out. 9 divided by 3 is indeed 3. So we arrive at the very obviously true equation, 3 equals 3. And so we got another one where, yes, 7 is a solution. All right, let's do one more. We got 32 equals 6 plus 2b, and we are being asked to verify whether or not b equals negative 15. So let's try it out. Let's substitute negative 15 for b, rewriting the whole equation the way it is, just with that one change. So 32 equals 6 plus 2b equals 2 times b. So I need to write 2 times negative 15. And I'm going to write that like this, 2. And then if I put the negative 15 in parentheses like this, that means to multiply them. So that's how I'm going to write it. Okay, so I've got an addition here and I've got a multiplication. PEMDAS says let's do the multiplication first. So I'm going to go down one line just doing that one operation. So I got to write it again. I'm going to write 32 equals 6 plus, well, 2 times 15 is 30. But we got positive times negative, so this is negative 30. I'm going to write 6 plus negative 30. Okay. Let's see here, 6 plus negative 30. Remember, the trick to adding a positive and a negative number is to subtract them, bigger number minus smaller number. So in this case, 30 minus 6, which is 24. So I'm going to write a 24 there. But then that answer is either positive or negative 24, depending on which of these numbers was bigger. And when I say bigger, I really mean their absolute value. 30 has bigger absolute value than 6, and it was the negative number. So this is negative 24. So we arrive at this equation here at the end that says 32 equals negative 24. Hopefully you can see that that's obviously not true. So let's cross those equal signs out to say that it's not equal. And let's write a conclusion that says no, negative 15 is not a solution to the equation. I'll go ahead and write the whole thing this time since it's my last one. You still got 5 more to do though. Good luck.